Okay, so we're going to talk about inverse functions. And so there's a bunch of words on here that kind of explains what an inverse is. So if you think about the function 2x plus 1, if you take numbers and you put them in for x, they're transformed into other numbers. So if I put 3 in for the x, you multiply it by 2 and add 1, you get 7. You put negative 2 in for x, you multiply it by 2, add 1, you get negative 3. So one number is transformed into another number. And so an inverse is going to take the 7 and turn it back into a 3. So it undoes everything the original function did. It'll take a negative 3 and turn it back into a negative 2. So can you guys think of a function that's going to take 7 and turn it into a 3, and then negative 3 and turn it into negative 2? And just a hint, it is going to use these numbers. It's going to use a 1 and it's going to use a 2. It's not going to do the same thing. It's going to kind of do an inverse of it. So can you think of a function that would do that? That you could do the things to 7 and turn it into a 3 that involves 1 and a 2. Anybody want to try? Anybody? Okay, so what you could do is take 7, and instead of adding 1, you could subtract 1 from it. And then instead of multiplying by 2, you can divide by 2. So that takes 7 and turns it into a 3. And then the same thing if it was negative 3. Oops, sorry. Subtract 1 from it and divide by 2. It's going to give you the negative 2. So the inverse function, to write an inverse, is actually f to the negative 1 of x. It would be x minus 1 divided by 2. Now, I'm not going to have you guys figure these out in your head. That was just to kind of get you started thinking about what an inverse is. So it just undoes what the original function did. Okay, now not all functions are going to have an inverse function. So to determine if a function has an inverse, you're going to use the horizontal line test. Do you guys remember another type of line test? The vertical line test? Okay. Well, the vertical line test tested to see if something was a function. So if you had something like this, if you took a vertical line and it always only crossed at one place, it's a function. Now the horizontal line test, you take a function, and if the horizontal line ever crosses at more than one place, then it fails the horizontal line test, and the inverse does not exist. All right, so another one could be like this. Could there ever be a horizontal line that would cross this blue one at more than one place? What do y'all think? Now, every horizontal line, if I can't move it, but if I took it and moved it up and down, every horizontal line would only cross at one place. So then this one passes the horizontal line test, and it has an inverse. Okay, so the first step when we are finding inverses is just to decide if the inverse exists, if it even has an inverse. And so that's number 1. You're going to use the horizontal line test to determine if the inverse function exists. And if it doesn't exist, then you just say the inverse does not exist. If it does, then we need to go on to the next steps. And so then, yeah. So then for step 2, you're going to switch x and y. That's an easy step. Now, step 3 is going to be the most complicated out of all the steps, and it is to solve for y. Now, sometimes solving for y is just like adding and dividing or subtracting and multiplying, but sometimes you have to do roots, and sometimes you have to raise to power. So step 3 is definitely the most challenging step. And then step 4 is the easiest step, really. So if the original function was written in function notation, which is f of x, and then you're going to replace y with f inverse of x. Right. And we are not going to worry about this last step. I don't think it's going to matter for what you guys are going to have to do. So we're just going to not worry about that last step. If you guys take pre-calculus next year, we'll talk more about that part of the problem. So on our assignment, we're also just going to not worry about that on the back. Okay. And so letter A is f of x equals 3x minus 4. Do you guys know what this graph would look like? A line, parabola, something swirly? Anybody? This is going to be a linear function. It's going to look something like this. And pretty much every line except a horizontal line is going to pass the horizontal line test. So just to save on time, I'm not going to graph this one in the calculator. We'll do a lot of them in the calculator, but this one is good. Well, it's a line. I know it's a line because the x doesn't have a power or anything. So if there's no power, there's no square root or no fraction or anything, it's going to be a line. It's going to pass. Okay, so now we're going to do the steps to find the inverse. So the first step is to switch x and y, but this one doesn't have a y. What could y be? Y is represented a different way on this one. Do you guys know what y is here? All right, f of x is y. So just change f of x to y. All right, then we're going to switch x and y. So just make the y x and make the x y. And then we're going to solve for y. So there's two things that are going on. The y needs to be by itself. We have this 3 and we have this 4. Which one of those would you take care of first? The 4. So whatever is added or subtracted to y, we're going to move it over first by, if it's minus 4, you add it. If it was plus, you would subtract it. All right. And then what do we do with the 3? Divide by 3. All right, and I'm just going to leave this a big chunky fraction. So our original problem was f of x, so this is going to be f inverse of x is just equal to that fraction. There's no reason for you to try to divide each by 3, just leave it like that, fraction. All right, any questions? Okay, let's look at the next one. All right, this one you probably don't remember what this looks like. We didn't spend a ton of time on cube root functions this year. So I'm just going to go to y equals. And anytime you guys need to get cube roots, if you hit the math button and then choose number 4, that's always going to be the cube root. So this is what a cube root function, this one's been shifted over to the right, but would this one pass the horizontal line test? It actually would. It's kind of tricky. It's okay. It kind of looks like it's horizontal, but on the left, it's going to keep dropping. On the right, it's going to keep going up. So no horizontal line would ever cross more than one place. So this one passes the horizontal line test. If you wanted to do a little graph of it, it's up to you. It kind of looks like that. So the horizontal line test, check. If it fails, it's going to be obvious. It won't just look like it goes horizontal. It will like swoop up or swoop down or something. Okay, so we are going to switch x and y. And then we're going to solve for y. So this is tricky. We haven't really done this in a while. But do you guys remember what we do to get rid of a cube root? I'll give you a hint. You raise it to a power. Another power. The third power. So cubing gets rid of a cube root. So this is going to be x cubed equals that cube gets rid of the cube root, and we're just left with y minus 2. Right, and then our last step is just move that 2 over. So f inverse of x is the cube root. Nope, just kidding. X cubed plus 2. That function would undo everything the original function did. All right. We're going to look at C because this is one I would think you don't know what it looks like. We don't really talk about this 2/3 functions until calculus, really. Okay. That's what that graph looks like. Would this pass or fail the horizontal line test? This definitely fails. So I'm just going to draw a little graph over. I tell my calculus students this graph because they have to kind of memorize what it looks like. It looks like birds flying in the sky, like when you were a kid drawing. I don't know. When I was a kid, I used to draw birds flying in the sky that looked like that. But it definitely fails. And so these are going to be your favorite ones. When it fails, all you're going to do is say the inverse does not exist. And your time. Now D is tricky looking. We're going to use this function, but we're going to use it only for x's that are greater than or equal to 1. So to type it in the calculator, you'll go ahead and do the x minus 1 to the 4/3. But to get to the last part, you're going to do divided by, and then x is greater than or equal to 1. And if you guys have ever worked on programming graphing calculators, I don't know if some of you have, that you probably know where the greater than is, but if not, it's okay. To get the greater than or equal to, you're going to hit seconds and then math. Okay, so just type it in like normal, and then do divided by, in parentheses, x, and then greater than, like I wrote, was second math, number 4. So it's just half of a graph. And so pretty much all the ones that if you see this for all x's whatever, it's going to pass the horizontal line test. So you probably could just say it checks off without even checking. So if you forget how to do that, greater than, don't worry. It's just find the inverse. It's going to be fine. All right, so we'll go ahead and switch x and y. And then we're going to solve for y. And again, it's been a long time since we've solved equations like this. But if we want to get rid of a power of 4/3, we're going to raise to the reciprocal. We're going to raise to the 3/4. Right? Now, the reason that works is because the rules for exponents, you would multiply that and you would just get 1. And so they cancel each other out. Right, and then finally, we would just add that 1. And this one was h, so I'm going to call it h inverse of x is x to the 3/4 plus 1. All right, any questions? Okay, this one I need to change. Okay, now to save on time, I'm just going to show you what this graph looks like. It's going to be a square root graph that's shifted 2 to the left, so it's going to look something like that. Would that pass the horizontal line test? Yes. All right, so we're going to switch x and y. And then solve for y. So what do you think you do to get rid of a square root? Anybody? You're going to square both sides. And so that square just cancels out the square root, and you're just left with y plus 2. And we'll subtract that 2. So this is going to be g inverse of x is x squared minus 2. Okay, it's got a couple more. I know there's a lot of examples today, but oh, and this one I want to change this less than. Let's just change it to a greater than. All right, so like I said, if we wanted to look at this in the calculator, we would do the same things that we did last time. But I can just tell you that for sure, because I have this, I know it's going to pass. So what this is half of a parabola, really. It looks like that. Or this is -3. All right, so we'll switch x and y. And this one is about as complicated as they get. There's 3 steps to solve this one. I don't think you'll have any where there's more than 3 steps. But we have a 3, a square, and a 1. Which one would you move first? You ready? 3, squared, or 1? Remove the 1 first. So anything added or subtracted, that's the first thing you move over. So it's like you work out from the most farthest outside to inside. Now that 3 is trapped. We can't do anything with the 3, but we can get rid of a square by taking the square root of both sides. Now normally, if you do the square root of both sides up at this step, you would have to do the square root, and that 1 is going to be trapped. Why square root it? Why can't you just move over the square? To move over the square, you take the square root. To get rid of the square, you take the square root. Because the square root is something squared, they cancel each other out. And you're just left with what's underneath. All right, and then finally, we're going to add that 3. All right, so f inverse of x is going to be the square root of x minus 1. And then that minus 3 needs to be on the outside. Right, and then this last one is an absolute value graph. Do you guys remember what absolute value graphs look like? It's a letter in the alphabet. Y'all got a lot to remember. Okay, absolute value graphs are V graphs. And so if you remember that, then you're going to know that this last one is not going to pass the horizontal line test. But I just want to refresh your memory on how to type it in. So when you need to get absolute value, you're going to hit math. And then just kidding, I lied. You're going to hit alpha window, and it's number 1. So alpha window is a place where there's several things that we've used this year: absolute value, summation, log base. So absolute value is second window, number 1. All right. So like I said, it's going to be in the shape of a V. V graphs are not going to pass the horizontal line test. So it looks like this. So it fails. So you just have to say that the inverse does not exist. And that's it.